Here's a basic example of solving an absolute value equation. So we're going to start out by expressing it in piecewise notation, and we do that by taking whatever we have inside the absolute value here and setting it equal to 0. This will allow us to solve for that invariant point, which is the point on our absolute value graph, where our graph basically turns around and continues in the positive direction. So if we're solving here for x, and we rearrange this equation, we get x equals -3. So -3 is our invariant point. So if we express this in piecewise notation, it's going to look like this. We have the positive absolute value case and the negative absolute value case. And our invariant point here is -3. So our graph is going to be positive if x is greater than or equal to -3, and it's negative if x is less than -3. And you could graph this absolute value function in order to verify this. We could have a look at it visually. Okay, the next step is to solve for each case. So with our absolute value equation, we have x plus 3 equals 8. Now this absolute value can be either positive or negative. So we solve each individual equation. So x plus 3 positive and negative x plus 3. In this case, we get x equals 5. Here, we distribute the negative through the brackets. So negative x minus 3 equals 8. Add 3 to both sides. And we get x equals -11. Or positive 11, sorry. And we divide both sides by -1. And x equals -11. So -11 and +5 are our two solutions. Last step is we just have to check these out. So left side of our equation is absolute value of x plus 3. The right side is 8. So we substitute in our solutions to make sure left side equals right side. 5 plus 3 is 8. And the absolute value of 8 equals 8. So this one works. Here we'd sub in -11 plus 3. -11 plus 3 gives us -8. Absolute value of -8 equals +8. So it works for both solutions. So we do not have an extraneous solution in this case.